Suppose let's we have a single features. We have a x is a single features we have. It is a simple single features. Okay, so some problem, suppose we have some problem, based on the domain expert knowledge, we need to convert these features into some mathematical form, like that, like that. Like it we have need, we maybe need log x, some kind of transformations, or exponential, some kind of transformations, or we may need this kind of transformation, square root of x, like that, or cube third root of x, like that kind interaction we need, or somehow we can need this kind of interaction, x square, x cube, x to the power 4, like that, polynomial kind of transformation. Or maybe we need some trigonometrical transformation like sin x, like cos x, like that, tan x, like that. Okay, so these things are based on the problem to problem. So it's based on the problem to problem. So the questions, for these questions, what is the best transformations? What will be the best transformation? What will be the best transformations? So it's depend on the problem to problem. Simple, its answer will be problem specific. First, it's problem specific. It's very problem specific. The second thing is domain knowledge we need. We need domain knowledge. So when we'll discuss the case study, various case study, then we will see. By using the case study, we will see its application. When we discuss the case study, then we will see. Now let's try to understand through an example how much these things is supposed. Already in statistics and probability series, we have completed some kind of distributions that are in general used in the machine learning. We have completed this thing. Suppose let's try to understand through this example. Okay, suppose the interaction, the variable x that have its sum follows the power law distribution. Its sum follow the power law distribution. Its sum follow the power law distributions. Okay, if we know if some variables follows the power law distributions, then in general we apply onto it the log x. Log x. Or simple it's we can apply it's the box Cox transformation, because we have already seen. If we apply onto it the log x or simple box means log x is the one case for these box transformations. We have already known this thing. So if we simple apply this onto log x, then we can easily find the another kind of distributions onto it, means Gaussian kind of distribution. Gaussian distributions, we got it onto it. Okay. So if we got the Gaussian distributions, then we have some beautiful property onto it. Beautiful property onto it. And by using this property, we can take some decisions. Okay. We already known these things. So just this kind of here actually this is these features, these x features, we have used these mathematical transformations to build another kind of features that we can easily take, take some easy decisions onto it. Okay, this is the thing. Okay, this it's mainly I think you go from these examples you got some idea how these mathematical transformations are useful to make some to convert some features to another type of features. Okay, when we discuss the case study, various case study, we will see its applications. I think you got the idea how mathematical transformation is needed in features in engineering.